Hello everyone, welcome back to my channel Logical Domain of DJ with another powerful mathematical session, which one is first order derivative. So in our today's video we will do some important first order derivative which are very much important for any board exam or any other competitive exam. So follow the video. I hope end of the video you will learn some technique, some simple way how can we approach, how can we calculate the first order derivative in simple way. So our first one is y equal to log base 10 root over x minus a plus root over x minus b. We have to calculate the derivative of this function. Now the first problem, the base of the log is 10. Our formula, that is ddx of log x equal to 1 by x, but this formula log has base e. So first of all we have to change the base of the log. How can we change them? We can write this one by base changing rule. In this way, this is the base changing rule. Just you can think this e and this e will cancel and log base 10 is remains same. Now this one is constant. So when we take the derivative, that is dy by dx, this one is constant. So this one remains same. We have to calculate just derivative of this function. Now we know the chain rule, that is we will think this one log x, and what is its derivative? 1 by x. But what was x? This one is x. We have to calculate its derivative. Clear to everyone? This one is chain rule. So what it will become? This one equal to log e base 10 1 by root over of x minus a plus root over of x minus b. Now derivative of root x. What is the derivative of root x? Derivative of root x is 1 by 2 root x into derivative of x minus a. What is derivative of x minus a? 1 minus 0 plus this one also same, 1 by 2 root x into derivative of x minus b, that is 1 minus 0 log e base 10 if you take this half as common and add them, x minus a into root over of x minus b. Now see, this term will cancel. So what is the result? Half log e base 10 1 by, you can write in this way, x minus a, x minus b. That is our result. So clear to everybody? How can we apply the chain rule and calculate them, and we will get our desired result. Now same types of problem, number 2. y equal to log x plus root over of x square minus a square. This is a very common structure of logarithm. So what is dy by dx? Derivative of log x, that is 1 by x, into now derivative of this function. What is the derivative of x? 1 plus this one is root x. I will think as root x. So derivative of root x is 1 by 2 root x. Then derivative of x square minus a square, that is 2x minus 0. So you cancel them. What you will get? If you add them, you will get x square minus a square plus x root over of x square minus a square. See here also this term is cancelled and you will get your required result, that is root over of x square minus a square. So this is the application of chain rule. Log x derivative is 1 by x, then derivative of this part, derivative of x is 1, derivative of root x is 1 by 2 root x, and derivative of x square minus a square is 2x. Calculate them, you will get the result. So derivative of this function is this one. This is a very important result. So you can remember this result. Number 3. Number 3 problem. Y equal to x plus root over of x square plus a square whole to the power n. This is very similar structure of our previous problem. If we take log both sides, log x plus root over of x square plus a square whole to the power n. And you know that is a property of log. This power n will come as multiple in the left side. So this will become n log x plus root over of x square plus a square. Now I will take the derivative on both sides. ddx of log y equal to, this n is constant, ddx of log x plus x square plus a square. Now what will be derivative on the left side? Derivative of log y is 1 by y, but this is a function of y, so by chain rule we have to multiply dy dx as a multiple. Now its result from the previous problem, this derivative of this function is 1 by root over of x square plus a square. So what is dy dx? This y will come here, ny by root over x square plus a square. That is our required result. So in this way, taking log from the both sides, we can calculate the derivative in a simpler way. Now for the next problem, number 4. Number 4 is tan y equal to root over of 1 minus x, 1 plus x. Now how can we calculate its derivative? That is, we have to calculate dy by dx. So before applying derivative, first we simplify the function using trigonometric rule. Suppose if we substitute this x as cos 2 theta, then what you will get? 1 minus cos 2 theta, 1 plus cos 2 theta. What is this one? This one is tan square theta, and you get only tan theta. So your function becomes tan y equal to tan theta. That is y equal to theta only. Now what is theta? Theta is 2 theta equal to cos inverse of x, theta equal to half of cos inverse x. So your function becomes only half of cos inverse of x. So see, our function becomes more simple. Now you can do its derivative. Dy by dx, half is constant. Cos inverse x, its derivative is minus 1 by root over 1 minus x square. So our required result is 1 by 2 root over of 1 minus x square. That is our answer. So see, before calculating derivative, first of all we have to simplify them if possible. Then the derivative becomes very easy. Simple, same types of problem number 5. Y equal to tan inverse root over 1 plus sin x, 1 minus sin x. This one also very important structure. Now see what we can write as 1 plus sin x. 1 plus sin x means you can write this one cos square x by 2, sin square x by 2 as 1 plus 2 cos x by 2 sin x by 2. So see, this is a perfect square number. This one is cos x by 2 plus sin x by 2 whole square. If there is minus, there will be minus and this will be minus. Now, so what will be this structure? This one is cos x by 2 plus sin x by 2 whole square, cos x by 2 minus sin x by 2 whole square, its root. So square and root will vanish. So what you will get? Only this one. Now you know this is a very conventional structure. You can easily convert it in the form of tan by dividing cos x or cos x by 2 in numerator and denominator. So it will become tan inverse 1 plus tan x by 2, 1 minus tan x by 2, and this one is tan inverse tan pi by 4 plus x by 2. That is only pi by 4 plus x by 2. So see, now your y becomes this one, pi by 4 plus x by 2 only. So this is a very simple function. You can easily calculate its derivative. What is dy by dx? Pi by 4, this is a constant, its derivative 0. X by 2, its derivative only half. That is our result. So clear to everyone? So this is a very important trigonometric function which can be easily deduced in a simple form. Then you take its derivative and it will be very simple. Number 6, y equal to tan inverse 1 plus x square root minus 1 minus x square root we have to calculate its derivative. Here also we will do some trigonometric calculation before doing our derivative. Here we replace x square equal to say cos 2 theta. Then 1 plus x square means 1 plus cos 2 theta. And what is this one? 2 cos square theta. And 1 minus x square means 1 minus cos 2 theta, that is 2 sin square theta. So if you replace here, then what you will get? Root 2 cos theta minus sin theta, root 2 cos theta minus sin theta. This root 2 to cancel. So this also deduced in our conventional structure, that is cos theta minus sin theta, cos theta minus sin theta. And you can easily convert them in the structure of tan. So it will become tan inverse tan pi by 4 minus theta, and you will get only pi by 4 minus theta. Now what is theta? Theta equal to half of cos inverse x square. 2 theta equal to cos inverse of x square. So theta equal to half of cos inverse x square. So if you replace them, your function becomes in this structure, half of cos inverse x square. So now its derivative is very simple. What is dy by dx? This one is constant, its derivative is 0, minus half cos inverse x, its derivative is minus, so plus it will become plus. So 1 by root over of 1 minus x square, that is x to the power 4, into derivative of x square, that is 2x. So 2 to cancel, only result is x by root over of 1 minus x to the power 4. That is our desired result. Y equal to a cos x minus b sin x. No, here also tan inverse exists. By b cos x plus a sin x. Now if we want to convert this structure in tan, here it becomes 1, this will become 1. So we divide the numerator and denominator by b cos x, then what you will get? Tan inverse of a by b minus tan x, this one is 1 plus a by b tan x. Now if you think this a by b equal to something tan alpha, say, then what it will become? Tan inverse of tan alpha minus tan x, 1 plus tan alpha into tan x. So this one is our standard result, tan inverse tan of alpha minus x, that is only alpha minus x. Alpha is a constant number, so what its derivative? dy by dx is, this one is 0 minus 1, result is only minus 1. So in this way your derivative will be very simple if you convert the function in a very simple structure. y equal to tan inverse 3x by 1 plus 4x square plus tan inverse 2 plus 5x 5 minus 2x. Now see how can we convert the structure. We can write this 3x as 4x minus x, this one is 1, 4x into x. See this one is tan alpha minus tan beta, 1 plus tan alpha tan beta. Here first of all we make this 5 as 1, that is we divide this numerator and denominator by 5. Then this one is 2 by 5 plus x 1 minus 2 by 5x. Now replace this, suppose say x equal to tan alpha for x equal to tan beta, 2 by 5 equal to tan gamma. Then what you will get? Tan inverse, this one is tan beta minus tan alpha, 1 plus tan beta tan alpha plus tan inverse tan gamma plus tan alpha, 1 minus tan gamma tan alpha. So this one tan inverse tan of beta minus alpha, tan inverse tan of gamma plus alpha. So beta minus alpha, gamma plus alpha. This alpha alpha cancel, only beta plus gamma. What is beta? Beta means tan inverse of 4x. And what is gamma? Gamma means tan inverse of 2 by 5. Now see this one is constant. So only we have to derivative of this value tan inverse of 4x. So what will be our derivative? Our derivative is tan inverse of 4x, that is 1 by 1 plus x square, that is 6x square. Derivative of 4x is only 4 plus 0. So 4 by 1 plus 16x square. This one our result. Given in this way, 1 minus x square 1 minus y square equal to a into x minus y. You have to calculate its derivative. How can we do this derivative? First of all, see this structure root over of 1 minus x square or root over of 1 minus y square. This structure is very similar 1 minus sin square theta or 1 minus cos square theta. In this structure, that is, if you replace here x as sin theta or cos theta, you will get simply this one is sin cos. So before calculating derivative, we calculate this function in trigonometric function, in trigonometric way. Suppose replacing here x equal to sin theta and y equal to sin phi. Then what we will get? 1 minus sin square theta, 1 minus sin square phi, a into sin theta minus sin phi. So 1 minus sin square theta is cos square theta, that is only cos theta. This one is cos phi, a sin theta sin phi. Now cos c plus cos d, you know its formula, 2 cos c plus d by 2 cos c minus d by 2. This one is sin c minus sin d. Its formula is 2 cos c plus d by 2 into sin c minus d by 2. So 2 to cancel, this one also cancel. Now if you take this sin to the left hand side, cos by sin, that is cot, equal to a. Now then also we are not doing our derivative. We convert this cot to the right side. So what we will get? Theta minus phi by 2 equal to cot inverse of a, because this one is constant. So if you take a derivative, it becomes 0. You also shift this 2 to the right side, that is theta minus phi equal to 2 cot inverse of a. Now what is theta? Theta equal to sin inverse of x and phi equal to sin inverse of y equal to 2 cot inverse of a. That is our simplest structure. You can easily take the derivative of these two functions and its derivative is shunno, its derivative is 0. That is 1 by root over of 1 minus x square. This one is 1 by root over of 1 minus y square, but this is a function of y, so you have to multiply dy dx, and this one is 0. Then what is dy by dx? Root over 1 minus x square, root over 1 minus y square. That is our result. So clear to everyone? That is how do we approach in this problem. Trigonometric calculation is mandatory before calculating actual derivative. Otherwise, you cannot reach your goal. Now, same type of problem. Number 10. Y root over of 1 minus x square, x root over of 1 minus y square equal to 1. Here also we replace, say x equal to sin theta, y equal to sin phi. Then this one sin phi, 1 minus sin square theta, that is cos theta, x is sin theta, 1 minus sin square phi, that is cos phi, this one is 1. So see, this is sin theta cos theta sin a cos b plus cos a sin b, that is sin a plus b, sin phi plus theta equal to 1. Now shift this sin to the right side, theta plus phi equal to sin inverse of 1. So what is theta? Theta is sin inverse x, phi is sin inverse of y equal to sin inverse of 1. Now you do your derivative. Then root over 1 minus x square, root over 1 minus y square, but this is a function of y, so by chain rule you have to multiply dy dx to the right side and its derivative is 0. So result is minus root over 1 minus y square, root over 1 minus x square. Now number 11. This is almost same structure but little different. Equal to 0. Almost looking the same structure, but it's not same, because it's not our 1 minus sin square or 1 minus or 1 minus cos square structure. This one is only y, this one is only x. So you cannot replace here sin theta or cos theta. So what can we do here? First of all, we shift this right side, that is y root over of 1 plus x. Now square both sides. If you square both sides, this one x square plus 1 by y, this one y square 1 plus x. Multiply them and take all the terms to the left side. Then what we will get? X square y minus y square minus x square equal to 0. Now factorize them. Simple, just rearrangement. X plus y into x minus y, xy, x minus y. Now here x not equal to y, so this term becomes 0. So only you get x plus y plus xy equal to 0. That is our simple structure. Now we have to calculate dy dx. Now y into 1 by x, this one is minus x. Now what is y? Minus x by 1 plus x. Now you take its derivative, that is dy by dx. This one is u by v, 1 plus x whole square, 1 plus x into 1 minus x into 1. Now what you will get? 1 plus x minus x, it's a whole square. That one, our result. So this is also very important problem, frequently come in various types of competitive exam or board exam. Now see another problem is sin inverse x square minus y square, x square plus y square equal to x equal to k. Sorry. Now how can we calculate its derivative? See what here we will do. See, this is a component of dividend structure. So first of all, we shift the sin inverse to the right side. So what we will get? X square minus y square, x square plus y square equal to sin k. Now if you do component dividend to the both side, then what will become? Suppose x square plus y square plus x square minus y square, x square plus y square minus x square plus y square equal to 1 plus sin k using component and dividend. So this one only x square by y square equal to 1 plus sin k. So if you square root them, x by y equal to root over of 1 plus sin k, 1 minus sin k. So clear to everyone? Now see this function which deduced in a simple structure, whose right side is a constant. 1 plus sin k, 1 minus sin k, root of this one. So this one is constant. And when you take its derivative, this will vanish. Then what will happen? This one is u by v structure. V square y into derivative of x is 1 minus x into dy by dx equal to 0. So this will also become 0, that is y minus x by dy dx equal to 0. So what is dy by dx? Only y by x. So its result is very simple. Now come to another structure, number 13. X to the power m into y to the power m equal to x plus y whole to the power m plus n. Y to the power n. Now this is a very conventional structure. Its derivative will be only y by x. You can remember it as a formula. I will prove here. Take log both sides. Log x to the power m, y to the power n. Log x plus y whole to the power n plus n. Now using the property of logarithm, what you will get? M log x n log y equal to m plus n log x plus y. Now take derivative from both sides. This one is m by x, this one n by y into dy by dx. M plus n is constant. Log x derivative is 1 by x, derivative of x is 1, derivative of y is dy by dx. Now we take all the dy dx term to the left hand side. I write in this way: m plus n by x plus y into 1 plus dy by dx. Now I take dy dx to the left hand side. This term x by y, and from the right side we will get m plus n by x plus y equal to, here m plus n by x plus y minus m by x. Now dy dx equal to this term by this term. So if we calculate them, y into x plus y, mx, sorry, this one n by y, sorry, nx plus ny minus my minus ny equal to, here is this one x plus x into x plus y, mx plus nx minus mx minus my. So mx is cancelled, here ny is cancelled, x plus y you can cancel them, dy by dx, nx minus my by y, nx minus my by x. So see, this term also same, so you can cancel them. So what is dy by dx? Only x by y. That is our result. Sorry, y by x, not x by y, y by x. In this way, x cube y to the power 4 equal to x plus y whole to the power 7. Then what is dy dx? Now dy dx is only y by x, whatever may be the value, x to the power m, y to the power n equal to x plus y whole to the power m plus n. x plus y whole to the power, you can write in this form. Then its result is this one, dy dx is y by x. X to the power y, y to the power x equal to 1. How can we calculate its derivative? There is no such rule in derivative, x to the power y or y to the power x. Now how can we derivative of this function? Suppose this one is u and this one is v. That is u equal to say x to the power y. How can we derivative of this function? Take log, that is log u. Log u equal to y log x. Now you can do it derivative. What is derivative? 1 by u du by dx equal to, this one is u by v rule, y constant 1 by x, log x constant dy by dx. So what is dy dx? Dy by dx. Similarly, what is v? V equal to y to the power x. Take log both sides, log v equal to x log y. Now derivative is 1 by v dv by dx. This one also u by v, uv rule, x 1 by y dy by dx plus log y 1. And what is dv by dx? V into x by y log y. So these two structures is our necessity. Now our function, what is our function? Our function was u plus v equal to 1. Now if you take derivative on both sides, du by dx dv by dx equal to 0. Now we replace the derivative of du dx from this, derivative of dv by dx from this one. Then what you will get? U means x to the power y. What is dv by dx? V into, v means y to the power x. X plus y dy by dx plus log y. Now we will take all the dy dx term to the left side and all the remaining terms to the right side. Dy dx. What we will get here? X to the power y into log x plus y to the power x into x by y equal to, right side there is a minus sign, x to the power y, y by x, y to the power x log y. So our derivative is, just write the structure in this way, x to the power y, y by x, y to the power x log y by x to the power y log x, y to the power x, x by y. This one is our result. So the problem, what was the given function, is looking very simple, but its result is too much long, and also you have to do in separate way. Otherwise you cannot calculate this type of function where base and index both are in variable. We have to take the logarithm and then calculate them. Suppose say x to the power y equal to say y to the power x. Take log both sides, y log x, x log y. Now take derivative, y 1 by x log x dy by dx, UV rule, here also UV rule, x 1 by y dy by dx plus log y into 1. Take all the dy dx term to the left side, log x minus x by y log y minus 1 by x. So what is dy by dx? If you calculate them, x log y minus y, x in the denominator, y log x minus x, y in the numerator. So this one is your result. Sin y equal to x sin a plus y. You have to prove dy by dx equal to sin square a plus y by sin a. How can we calculate its derivative? Here we write in this way, x equal to sin y by sin square a plus y. Sorry, sin a plus y. Now we are taking derivative with respect to y, dx by dy. Then this one is u by v rule. What you will get? V square v into derivative of sin y is cos y minus derivative of this one is cos a plus y into 0 plus 1 derivative of a plus y. So what will get here? Sin a cos b, cos a sin b. This one is only 1. So this one is sin a plus y minus y by. So this one is what required result, sin a by sin square a plus y. This one is dx by dy. Now what is dy by dx? You just reverse them, that is dy dx is sin square a plus y by sin a. So these are the various types of difficult function derivative. You already learned how can we calculate this difficult function. Before calculating derivative, we have to solve them, you have to calculate them, so that you can get a simple structure, and then you do your derivative and you will get your desired result. So up to now, I hope you have learned all the techniques, all the methods. There are also so many functions also, but using this concept you can do this problem. So do your problems, practice them. Without practicing you cannot do this problem in very simple way. So till then, smile up and carry on your studies. Thank you.